Alright, the last video in this series for this lesson. Okay, so actual dividing of polynomials. We need a little bit of vocabulary for this. There's actually an extra step to this process. We'll call it step 0. And that is going to be make sure everything is in standard form. So what is standard form? That's the real question here. That's a brand new term for us. We haven't heard that one before. So let's talk about what standard form is really quick. Standard form, and I'm just going to draw an arrow up here, is order of descending exponents. Okay. This really only matters for division by polynomials. When you're doing that reverse factoring or reverse distribution thing that we did when we were dividing by monomials as opposed to dividing by polynomials. When you're dividing by monomials, it really doesn't matter. When you're dividing by polynomials, it actually makes a really big difference. So it's actually kind of an important detail here. So order of descending exponents. So let's take a look at our example. I took a look through the homework, and I didn't see anywhere this is a problem. But as a general rule, you guys want to make sure that this is true. Otherwise, everything is going to get wonky and messed up. So here we have x squared minus 6x plus 5, order of descending exponents. So we want to look at the exponents. You want the largest exponent first, then the next largest, then the next largest, so on and so forth, for any given polynomial. So here we start with a 2, and then there's a 1, and then there's a 0 here. So that one's good. X minus 1, there's a 1, and then there's a 0 here. So yes, good. Order of descending exponents is good. So we have both polynomials in standard form. That actually does make a big difference later on, and especially in the process that you guys are going to see here, it makes a big difference. So we're going to set this up like it's a long division problem. Okay, this is going to be the dividend, and this is going to be the divisor. Okay, so it always goes dividend, divisor. Okay, is always going to be the order here. So we're going to go ahead and write this in using our bracket. So we have the division bracket. We have x squared minus 6x plus 5, and we're going to divide x minus 1 into this. Okay. The steps in this crop here, these are good here, so set this up in long division, then divide the first terms, distribute to all terms, line up and subtract, and then repeat the process. It's very, very similar to what you guys saw in the division algorithm, the long division video with numbers that we did, that I did in the previous video. When you are doing long division of polynomials, though, when you are trying to figure out what value to multiply into, all you care about is this first term on the divisor. Okay, this is the only value that matters. Don't just ignore the -1. We deal with that when we do our multiplication through. So the question we're going to ask here is, what do I need to multiply this leading term with, this x term? It's the leading term. I'm sorry. What do we multiply the leading term by in order to get x squared? So you have to think about your exponent rules here for a second. What do I need to multiply x by to get x squared? The answer is x. That's what's going to go on the top of the division bracket. Okay, so now we're going to multiply down. So x times x minus 1. So x times x is x squared. You have to make sure you line up your terms when you're doing this, or you're going to get it wrong. So make sure you line up the terms appropriately. So x times x is x squared. X times -1 is negative x. Oh, okay. Now we're going to add parentheses, and we're going to subtract from the above two terms. Okay. So distribute to all terms. That's what we just did. So we did divide the first term. That's how we got the x. Then we distribute to all terms. So x times the x minus 1. And we got this term. We got these two terms, x squared minus x. And now we're going to line up like terms, and we're going to subtract. So x squared minus x squared is 0. Negative 6x, a negative times a negative is a positive. So this is really plus x on this line. So negative 6x plus x is negative 5x. Okay, that's the end of that. Now we're going to bring down this term. And that's actually not put on here. That's actually supposed to be right here. Okay, we'll call that 4b. Okay, step 4b is bring down next term. Bring Okay, all right. So we're going to bring down the 5. It's a plus 5. Make sure you keep that straight. And we're going to repeat the process now. So x times negative, what do we have to multiply x by to get negative 5x? Just negative 5. So we're going to add a negative 5 here. Don't worry about the x. We're just concentrating on the negative 5 now. So negative 5 times x minus 1. Negative 5 times x is negative 5x. And negative 5 times negative 1 is positive 5. We're going to subtract that from what's above. These are opposites of each other, so when we subtract them, we will end up with 0. Okay? What this means, when you look at this here, is it tells us that x minus 1 times x minus 5 is equal to x squared minus 6x plus 5. Okay? Alright, you can check this. You guys can FOIL this out and see that it works. Okay, so what we do is we start off with the product. We start off with the result of FOIL. We're given one of the factors, one of the parts of the binomial expansion, and we can find the other term using long division. Okay, you guys should be able to do so. This one here is the one without remainders. These ones are pretty straightforward to do because they always work out to 0. Let's do one more example. I don't want to make this video super long, so I'm only going to do one other example, and then there's a third example in this packet that we'll do in class because it gets into a technical detail here, which is part of the reason why I want you guys to write everything in standard form. Okay, so let's go to the next example here. This one is going to have a remainder on it this time. You'll notice that it's 4 terms this time instead of just the 3 terms. So instead of having a largest term of x squared, our largest term this time is an x cubed. Okay. Sorry, my allergies are bothering me. So let's go ahead and rewrite this using our division bracket. So we're going to have x plus 2 and 4x cubed minus 6x squared plus 9x minus 3. We're going to repeat the same process as before. So in order to get 4x cubed, I have to multiply x by 4x squared. 4x squared times this whole binomial, that's going to give me 4x cubed. Then 4x squared times 2, 4 times 2 is 8, so that's going to give me a plus 8x squared. I'll subtract that from the line above. Make sure that you keep everything neatly organized here. It's really easy actually to get this wrong because you don't keep stuff lined up and everything. So make sure you're doing all the subtraction cleanly and stuff. Make sure everything's lined up. So 4x cubed minus 4x cubed is 0. A negative 6 x squared minus 8x squared. So negative 6 minus 8 is negative 14. So I'm going to have negative 14x squared, and then I'm going to bring down the next term, which is 9x. So I'm going to have a plus 9x. Rinse and repeat now. In order to get negative 14x squared, I have to multiply by negative 14x. So that'll give me, when I multiply negative 14x, we forget about the 4x squared now, we're just concerned about the negative 14x. Negative 14x times x will be negative 14x squared. Negative 14 times 2 is negative 28x. Subtract that from the line above. I'll get 0 when I subtract the negative 14s. And then a negative times a negative is a positive, so 9 plus 28 is 37x. We'll bring down the last term, which is a negative 3. Last term. X times, in order to get 37x, I have to multiply x by 37. Notice here how the powers on the exponents go down 1 each time when we do this. We have an x squared, then an x, and then we have our constant term. So 37 times x is 37x. 37 times 2 is 74, I think. 37 times 2 is 74. Okay. So we're going to get a plus 74 here. Subtract that, we'll get 0. And then negative 3 minus 74 is negative 77. Okay. X does not go into negative 77. Let me scoot this up now as you guys can see. There we go. X does not go into negative 77. Okay, so we have a remainder of negative 77. So we put that up here. Remainder of negative 77. You guys can confirm this. You can do lattice multiplication, or you can do the lattice multiplication like when we were doing polynomial multiplication, and you can see that x plus 2, it really helps if I hold this so you guys can see it. X plus 2 multiplied by 4x squared minus 14x plus 37, and then we have a remainder of negative 77, minus 77, okay, will be equal to 4x cubed minus 6x squared plus 9x minus 3. And you guys can try that. You can do the lattice multiplication and you'll see that this works out. Okay, so that's the remainder scenario that we end up having here. Sometimes this remainder here on the bottom, depending upon what the divisor is, it can actually be a monomial, or it could be a binomial. That does happen. It doesn't happen a lot, but it does happen. And you guys will see some problems like this on the homework where you'll end up with these remainders. Let's go to the next problem real quick here. I want to save this particular problem for doing in class. This comes back to monomials. One thing that you're going to notice here is that we're missing a term. We don't have an x cubed term. We go x to the fourth to x squared. Okay, we are missing two terms here. We don't have an x cubed term, and we don't have an x term. We have to address those. I guess I can actually show you guys these now. So if we're ever missing a term, we're going to put a 0 in its place, and I'll show you what that looks like. So what this is really saying here is x to the fourth plus 0x cubed minus 6x squared plus 0x, because we're missing the x term, plus 8 divided by x minus 2. Now you guys can actually solve this one if you wanted to. You can do the division algorithm and work it out. I will go over this problem again in class, but you guys can give this a try from here. Just remember the zeros are here. When you subtract from 0, it's going to be negative, and there's all sorts of things that come into play there. So make sure you keep track of what's happening when you're doing addition or subtraction with the 0. All right, and then there's some more practice problems here at the end, and we can take a look at these in class even more. Let me see here. What else do we have here? Nonlinear coefficients and some more practice. We'll take a look at some of these other examples during class. I don't want to overwhelm you guys with these videos because it's already been 3 of them. So we'll call it for the evening tonight. If you guys have questions, I'm sure there will be questions. This is one of the more complicated things that we have done in the class up to this point. So if you have questions, bring them to class, and we'll go over some more examples then.